Okay, let's do a teardown of this Replica Unitron clock drive. Give you another look at it. First of all, let's remove this. So first things first, let's remove this. So this part comes off here. Those are the little friction points down in there. You can see that when you screw this in, it causes that to come down. Now inside here, this thing here, there are a couple of, well, first of all, there's a locking nut here. The locking nut wants to hold this thing in one position, and it's very necessary because this thing really wants to walk out of there. The forces on this thing, there's a bearing up inside here. I'll show you the bearing here in a moment. The bearing up inside here really wants to make this thing unwind, walk out. So this has to be set just exactly right, and then this will be locked down to hold it in position. And this is the bearing that goes inside there. It's a little tiny ball bearing. Fits inside there. It's a pretty good friction fit inside there. So that little thing, that's the top bearing for the 3-ball governor axle. Alright. Now here's the Replica 3-ball governor. It's ready to come out now. So let's pull this baby out. Alright. Down inside here is another bearing similar to that one, along with a washer or two. These are just basically spacers. And the idea is to hold the axle up while allowing the bearing to do the job of holding it with the axial rotation. Okay, and this little complicated thing, there's some exquisitely small parts here. These screws here are, I think it is 256. That's what these are. And this whole little cage here moves up and down. This is exactly like on the Unitron. The cage moves up and down, and this point here engages, and that's where the friction occurs, right about there, with those 3 little bronze fingers that reach down from above. Okay, so let's take all this apart. I think first thing I'll do is maybe pull off the balls themselves. Okay, there's one. Okay, I have to pull that out. Okay, with the cotter pins removed, you can see that's just a hunk of brass. This is basically, I think it's a 1024. It's a number 10 bolt, brass bolt, and you can probably see the turning mark, so I turned it down to get it down to the right size, and of course I had to drill a little tiny hole there. So that's very simple, straightforward construction. So that gets rid of those guys. Now let's take this other piece off. In order to get this brass piece off, I have to remove one of these. This one in particular. So I can get my Allen wrench underneath there. Look how tiny. Look at how tiny that thing is. And I even had to, I couldn't get one short enough, so I had to cut the darn things off. Little tiny things. Micro machinists, the guys that make the little tiny steam engines and things like that, those guys, and clocks and so forth, those guys are laughing at me right now because they think that's huge. I mean, for them, that's probably gigantic. For me, it's really tiny. Not used to working that small. Those guys are true, just true craftsmen of the highest caliber to be able to make those little tiny things. I have nothing but respect and admiration for those guys. Making those little tiny things, it just astounds me. And this guy, of course, is a little bindy. Alright, there we go. Now, let's see. Let's pull all this off here if we can. This is just that's just 3 set screws, and that's just a stop for where this thing lands. Each of these, I'll take one out so you can see. Each of these is just a little tiny, it's a hunk of brass, bored out. That's another one of those little 256, whatever those tiny little things are. So that screws in, and really, this has to rotate like that, and it's just rotating on the threads. I'm not sure if that's the way the Unitron is made, but I don't think there's anything wrong with it. It's not going to rotate much. It's not ever going to come all the way out. And that thing slides up and down like that. I don't think I'll take it all the way off. This gear here, that's a pinion gear from a slot car, 64 DP, 14 tooth. Okay, so you can see what that's like now. This thing here, this was a huge chore to make this. Making a tiny part, like if it had been 5 times bigger, it would have gone so much more quickly for me. I'm used to working on much bigger things. These little tiny little pieces in here that may not even come out. And it's the whole thing is, it's a cage that rotates and comes up, and there's a little tiny bit of friction that occurs with those fingers. It doesn't need to be really robust. As a matter of fact, I decided to leave it that way, leave it a little loosey-goosey. You can see that thing just comes up and down, up and down, up and down. You want it to be a fairly loose fit. You want it, of course, to engage with this, and it has to engage with that. It's got those 3 little chunks of metal in there that make sure it's going to engage with that. And then it just needs to drag a little bit. And if you look at it carefully, it only touches here a little bit. Touches, skiff, just a little tiny bit when it's running at a fairly substantial rate. It touches very, very lightly. These guys, I want to show you these guys also. These are huge 440s. Up until I started this project, this was the smallest I've really ever worked with. These are 440s holding these guys on here. Okay, so that's a button head cap screw, and I had to turn them down. You can see that it's not quite as the original would be. And I deliberately made this so that these were also loose fit. And it may not really, I think on the Unitron, those are glued, those are epoxied on, I believe. And that's probably fine. They probably don't need to rotate like this. But the way this is working, these are nice and tight. They're not going to come out. And the thing is free to rotate. No harm, no foul. And if this is slightly off, okay, no problem. What's going to hold those in position really is these right here. They go through there. That's what's going to hold those in position more than these. Let me show you, give you another look at that. I want to show you something that was a little surprising to me. And that is that if you look at this, the position, the distance from this out to here is actually, because it makes sense in retrospect, is actually closer than that. My original, the first time I made it, the first screw holes, I will confess, these guys are the first screw holes right there. I made them at the same distance, and of course, in retrospect, it's obvious that has to be further out to make this be tangential. Of course, you could, I suppose you could do it that way, but the way the Unitron was made was like that, so I replicated that. I think that's pretty much everything. That's all there is to this device. I don't think I'm going to take that whole cage apart. Well, I hope you've enjoyed my little teardown of this Unitron 3-ball governor replica. Thank you very much.